Imagine a world where ice didn't float. Picture lakes freezing solid from the bottom up, trapping fish in icy tombs. Envision oceans turning into vast glaciers, leaving no liquid water for life to survive. This isn't some dystopian fantasy, it's exactly what would happen if water behaved like every other liquid. But water doesn't follow the rules, it breaks them. In fact, water is the most bizarre, unpredictable, and downright strange liquid on Earth. Its oddities aren't just quirks, they're the very reason life exists at all. Take freezing, for example. Almost every known liquid contracts when it turns into a solid, becoming denser and heavier. But water does the opposite. When it freezes, it expands, becoming less dense. That's why ice floats. If it didn't, winter would be catastrophic. Lakes and oceans would freeze from the bottom, trapping aquatic life in ice and preventing sunlight from ever melting it. Over time, Earth's water would turn into one giant frozen block. Instead, ice forms a protective layer on top, insulating the liquid below and allowing ecosystems to survive. This single anomaly is the difference between a thriving planet and a lifeless wasteland. The reason for this strange behavior lies in water's molecular structure. A water molecule is shaped like a tiny V, with two hydrogen atoms bonded to one oxygen atom. These molecules are sticky, they cling to each other through hydrogen bonds, which are weak but numerous. When water freezes, these bonds lock into a rigid, hexagonal arrangement, creating empty spaces between molecules. This open structure makes ice less dense than liquid water, which is why it floats. No other common liquid does this, but water's weirdness doesn't stop there. It also has an extraordinary ability to stick to itself, a property called cohesion. You've seen this in action, when water forms droplets or when insects, like water striders, glide effortlessly across ponds. This happens because of surface tension, the result of all those hydrogen bonds pulling water molecules tightly together. This stickiness is so strong that water can defy gravity, climbing up thin tubes in a process called capillary action. Without this, trees couldn't transport water from their roots to their leaves, and entire forests would wither. Water is also a champion at storing heat. It takes a tremendous amount of energy to warm water up, and once it's warm, it holds on to that heat for a long time. This is why coastal areas have milder winters than inland regions. The ocean absorbs heat in the summer and slowly releases it in the winter, acting like a giant thermal buffer. This same property keeps our body temperature stable, preventing us from overheating too quickly or freezing in cold weather. No other liquid moderates temperature as effectively as water. Then there's water's unmatched talent as a solvent. It can dissolve more substances than any other liquid, earning it the nickname the universal solvent. Salt, sugar, gases like oxygen, even solid rock over time all succumb to water's dissolving power. This is why our blood, which is mostly water, can carry nutrients and oxygen to every cell in our bodies. But here's the twist: despite being able to dissolve so much, water refuses to mix with oils and fats. This selective solubility is crucial for life. It allows cells to maintain their membranes, keeping their delicate internal machinery separate from the outside world. And then there's the Mpemba effect, one of water's most baffling mysteries. Named after a Tanzanian student who observed it in the 1960s, this phenomenon occurs when hot water freezes faster than cold water. It defies common sense, and scientists still debate why it happens. Some think it's because hot water evaporates faster, leaving less water to freeze. Others believe convection currents in warm water help it lose heat more efficiently. Whatever the reason, this strange behavior is yet another reminder that water doesn't always play by the rules. Even the way water moves is unusual. Most liquids flow predictably, but water can form whirlpools, waves, and even bizarre hydraulic jumps when poured. Scientists studying fluid dynamics are still uncovering new surprises about how water behaves under different conditions. Its viscosity, or resistance to flow, changes depending on pressure and temperature in ways that other liquids don't. Perhaps the most mind-bending fact of all is that water shouldn't even be a liquid at room temperature. Molecules as small as water's usually exist as gases unless extremely cold. Yet here it is, flowing in rivers, filling oceans, and sustaining life. Without its strange properties, life as we know it wouldn't exist. Earth would be a barren rock, frozen or scorched, with no delicate balance to support living things. So the next time you take a drink, watch rainfall, or dip your toes into a lake, remember you're interacting with the most peculiar substance in the universe, a substance that breaks the rules, defies expectations, and makes life possible. Water isn't just another liquid, it's the strangest, most miraculous one of all.
Hey there, if you're enjoying this video and appreciate the effort behind it, don't forget to like this video. It really helps the channel grow, and if you haven't already, hit that subscribe button and turn on the notifications so you never miss an update. Oh, and one more thing, share this video with your friends. Spread the love and support. Alright, now let's get back to the video. Let me know if you want any tweaks.